Board. So hi, everybody. My name is Kate Cahill. I'm the Associate Director of High Performance Computing at NJIT. And I'm the PI of the Computational and Data Science Exchange Project, where we work on developing computational and data science curriculum and sharing it with faculty who can, so you can use these things in your courses, and then we want to host events to work with people to develop new materials. So we can, kind of expand the reach of these skills to students at all kinds of institutions. So this is an implementation project supported by the NSF. Previously, we had a pilot. And so our webinar series right now is sharing the materials and courses that we had developed within that pilot, which was just shared amongst the project members. And so we've had a session about visualization with Dr. Vitria Bird last time. And today we're going to hear from Ana Gonzalez, who was a professor at the University of Puerto Rico Mayagüez, and she developed a course as part of the exchange, Introduction to Modeling and Simulation. And so she's going to share materials from that course today, talk about the development and her experiences with it. And you can, ask questions, put them in the chat. We'll have time for questions at the end as well. And as I said, we have a site, a project site where we'll share all the resources from the webinars, including slides and recordings when they're available. And I put that in the chat, and I'll repost it in a minute for people coming in later. So Ana.
Okay. So let me share the screen.
Yeah.
Okay. Okay. All right. Okay, can you see the beginning of the presentation?
Yep.
Okay, good. So good afternoon. Greetings to everyone. First of all, I would like to thank the CDS Exchange team for the invitation. My name, as Kate said, is Ana Gonzalez. I recently retired from the University of Puerto Rico at Mayagüez. I taught at the Department of Mathematical Sciences for about 35 years. Approximately between 2017 and 2021, I was a member of the original CDS Exchange team, at that time known as the C-Square Exchange Pilot Project. So let me first present a brief preview of the webinar. So I will be sharing with you my experiences in developing and implementing a course in computation, modeling, and simulation. The primary goal of the course is to introduce basic concepts of computational science to a diverse student body. The aim is not to produce experts in computational science, but to provide basic skills. So the course could provide a panoramic view of the field and act as a catalyst to continue with more advanced courses. This was a great experience. I learned a lot, especially since it was done pre-pandemic, when recording videos and using YouTube was not as common. So I hope this webinar will be helpful in your courses and can generate ideas for future courses. So the presentation is divided into 5 major sections, going from an introduction to all the way down to what's next. Okay, so the course was developed as part of the C-Square Exchange project. The C-Square Exchange project was a National Science Foundation founded pilot project. We can think of it as a collaborative model for expanding access to computational and data science education. Among the main goals of the project, we can mention to share resources and develop course materials. University of Puerto Rico at Maya West was the co-lead institution together with Southern University, responsible for developing and offering the course. So it is generally accepted and it is well documented in the literature that computational science is key to future discoveries in all domains, as well as crucial to the competitiveness of industry. After reviewing the curriculum at my local institution, it was observed that the courses that address the topic of modeling, simulation, and data science have multiple advanced prerequisite courses. So it was hard for many students to take those courses. It was also noted that these courses are offered or were offered randomly, depending on enrollment and professors' availability. So with the main goal of introducing fundamental concepts of computational science into the undergraduate general education curriculum, the course was proposed, developed, and implemented as an elective course with only college algebra as a prerequisite. So with this mindset, the next step is to determine the learning outcomes of the course. So the competencies that guided the course design derived from the work developed as part of a project at the Ohio Supercomputer Center. The work is available at the site shown here at the bottom, hbcuniversity.org, and the group at OSC identified 7 competences areas. These are simulation and modeling, programming and algorithms, differential equations and discrete dynamic systems, numerical methods, optimization, parallel programming, and scientific visualization. Okay, so if you look into the hbcuniversity.org site, note that each area is further subdivided to describe the level of the skills and knowledge. So after a literature review, it was concluded that an introduction to computational science must equip learners with a basic understanding and an integration of both modeling and computer programming principles. So the focus was on the first 2 areas, which are, again, simulation and modeling, and programming and algorithms. Okay, so these are the selected learning outcomes of the course. Okay, going from the first one, explore the role of modeling in the sciences and engineering, going down to number 12, understand the modeling process, and lastly, demonstrate computational programming. Okay, so these are the course learning outcomes. So each one is further subdivided. The complete list can be found in the resources section at the webinar page, okay? So, for example, the number 12, understand the modeling process, is further subdivided in identify different types of models and simulations, describe the iterative development of a model, and explain the use of models and simulation for hypothesis testing. Okay. So with that, we come up with the course description. So the course description is an introduction to the principles of modeling and simulation, progressive introduction to programming principles and skills using a high-level programming language, application of programming skills to the solution of different classes of models. So the prerequisite is college algebra, but no experience with programming is required. Okay, so these are the course topics. In the resources pages, you can find the mapping of the topics with the corresponding learning outcome. Okay, so the topics align with the chapters of the textbook that was used. So this is the selected textbook, Introduction to Modeling and Simulation with MATLAB and Python by Gordon and Gilfus. And the reason for selecting the book was that its content focuses on meeting the set of basic modeling and simulation competencies selected for the course, as well, and this is very important, as it's just-in-time approach to introduce both programming and modeling concepts. Okay, so Python and the Spyder Integrated Development Environment were selected as a platform to develop the programming skills. Python is free. It provides powerful tools and libraries like SciPy and NumPy for scientific computing, and Matplotlib and others for data visualization. So Python has a rich web ecosystem of pedagogical resources. So the pedagogical model used was the flipped classroom model. The flipped classroom model switches the typical face-to-face lectures and homework elements of a course. Instead of attending the traditional lecture, students engage with short videos, presentations, or other multimedia content asynchronously before the class period. The in-class period is spent in student-centered learning strategies such as active learning activities. And in this way, the instructor can spend more time guiding students and supporting the students' progress. So, guided by the course learning outcomes, the course materials developed consists of short videos from 5 to 15 minutes, practice exercises, walkthroughs, multiple choice questions, recorded demonstrations. So these, as well as the course evaluations, were made available to the students through the course management system, Moodle. Okay, so the videos and activities will be available at the Google site, which can be reached from the webinar page. Let me quickly, let's quickly take a look at the site. This is the general structure. Can you see it? Okay. Is it showing? Okay, so this is the general structure. It is divided in modules, okay? And it is being populated. It is under construction and it's being populated with the course videos and activities. Okay, so let's check briefly the module 1, and hopefully we can see some of the videos. Okay, so here are the videos, the activities. We might take a look a little bit later at some of the activities. And so these are the videos, and then each module, at the end of each module, you have a link that will direct you to the book companion exercises. Okay. So for this first module, the book companion exercises will look. Oh, this is the last one. Let me see. It will look like this. Okay. All right. So okay, so new material was made available in cycles of 1 week. Okay. Course content was organized in modules, so every week a new module was added. And again, the course materials were made available through Moodle. This is a snapshot of Moodle, of the Moodle page. Okay, so at the beginning of each week, the instructor offered a general introduction to the topics of the week with instructions of what was expected for that week. Each week also, the students took an in-class 15-minute multiple choice quiz of the materials of the current cycle. The idea is to provide an incentive for students to stay on top of the material. Okay, so in class, the students work on exercises. On occasions, they were required to submit their work. They could work by themselves or in groups. A solution was presented at the end of the week. Usually a student volunteered to discuss his or her solution to the class. This allowed for class discussions. Other times, everybody was required, either in groups or individually, to present their solution. Okay, so maybe we can briefly go back to one of the activities, perhaps of the first module. Okay, so for instance, one of the first activities was this one here, but they are provided with a video, and then review the video in the link, which is this video down here, which is about climate change. It is from PBS NewsHour, and they have to ask some questions. Okay, and for example, the first question is, describe how the scientific method and simulation are mentioned in the video. Okay. Another of the questions that they have to ask is, what is the hypothesis mentioned in the video? Okay. Also, another of the activities presented for this module 1 is, for instance, they are given a situation. They are given a situation. This one here. It says, suppose there is a local radio station that broadcasts the locations and prices for all the gas stations in your area. The question is, which should you buy from? Okay, so they have to meet in teams, in groups, and they have to present or prepare a presentation, and they have to answer, for example, list the assumptions, show the concept map, show the mathematical model, and so and so. Okay. Okay, so okay. So that's for the activities. Now, at the end of the semester, students are required to develop a document and present a project. Keep in mind that this is a foundational course. So the aim of the project is to provide the means for students to consciously go through the steps of the modeling process. To help guide the students with the topic selection and development, students were directed to the course textbook, where the last chapter provided a list of project topics and a set of reference materials for each topic. Okay, so for example, if we go back to the site and we come, let's see, we go to the last point here, final exam. It has the project specifications. You can see the project specifications, and they had to do like a proposal before actually submitting themselves to the project. They have to do a proposal and present it to the group. And here we also provide the rubric to grade the proposal. And also we have the book companion, which is helps with the a list of project examples that they can follow to come up with their own project. Okay. So the course was offered on 2 occasions. The first time it was offered in a flipped classroom modality, as we have discussed, but the second time as an online asynchronous modality due to COVID. Okay. So as an online distance learning course, it was observed that a few students made use of the virtual office hours. And so the main feedback they received was from the graded evaluations, as opposed to the immediate feedback obtained from the flipped classroom model. So in general, I would say that the students appreciated the in-class activities and the instructor support. Okay, so as you probably have had the experience, when you finish teaching a course, you start thinking about what to change for the next time, about new examples, new questions that you would like to include in the evaluations, new active learning activities. So what I did was I experimented with ChatGPT and Copilot to see how to create new material more efficiently. So let me present some of the results. Okay. So first, let's see how to use ChatGPT with YouTube. Okay, so we come here. This is the YouTube environment, and this is one of the videos from their course, okay, modeling terminology. And if we notice here towards the right of the screen, this is the ChatGPT symbol, which means that the YouTube summary extension has been installed. And what that means also is that if we click on that symbol, we will get automatically a tab with the ChatGPT environment. Okay, let me go up the way up. Okay, so we get that automatically, the tab and the ChatGPT environment, and we also get automatically a prompt. Okay, this is the first prompt that we get, and note that the prompt says summarize the following in 5 bullet points, and the following is this here, which is a copy of the transcript of the video. Okay, so what ChatGPT will do, it will just summarize in 5 steps the content of the video. This is a short video, so it's easy to see the summary. Okay, so I think this is a nice way to get a summary of a YouTube video. Again, another prompt that we could use is, for instance, suppose that we would like to have to generate a quiz of 10 multiple choice questions. Okay, so again, this is the whole prompt, and we are telling ChatGPT, based on the following text, and the text is the transcript from the video, create a quiz of 10 multiple choice questions in Akin format. So that means that I would just like to copy what ChatGPT provided directly into Moodle. Okay, so with this prompt, ChatGPT will provide the 10 multiple choice questions, and it will provide an answer for each one. For instance, what is a mathematical model? So it will provide the 4 options and then the answer. Very important, ChatGPT can make mistakes. So it's up to you, it's up to us to check and make sure that everything is right. Okay? So this is a quiz, a multiple choice quiz for that one video. Okay, so we could another prompt that we could use with ChatGPT is, for instance, create a test of 3 short answer questions. Again, the content would be the transcript of the video, and ChatGPT will provide for us the 3 questions, and it will also provide the answer. So we can either use these 3 questions directly into an exam, or we could provide these questions to the students and have them discuss in groups and then present to the class. Okay, so what else we can do? Perhaps we can ask ChatGPT to describe an assignment for us. Okay, so let's go back here and say, let's go back and say to ChatGPT, come up with this prompt. Describe an assignment for my first-year students. They have to demonstrate the skills to develop a static mathematical model and coding in Python. The topic is the equilibrium forces in a seesaw. Provide the necessary theory. They need to calculate the distance for the second person to obtain equilibrium. The students are not yet introduced to functions or conditional statements in Python. So this would be a good assignment for the second week of class, where they have just been introduced to the different types of models, and they have been introduced to variables, operators, and the Python environment and Spider. Okay, so they have not yet been introduced to functions nor conditional statement in Python, and they will practice with variables and operators and the input function and print. So ChatGPT will come up with a homework, an assignment. It will provide an objective. It will provide the background theory, as well as the task. What are the students supposed to do? Okay. So we can also say, okay, we can tell ChatGPT again, provide the learning outcomes and the rubric to assess the assignment. And ChatGPT will provide the learning outcomes and a rubric to grade the assignment. Okay. So we can also say many, many other things. For instance, we can say, okay, provide me with a similar assignment, but for a different topic. And here's a different topic, projectile motion, calculating projectile motion, and so and so. Okay, so I said at the beginning that I would say something about Copilot also. So we would like to provide an example, have an example of data sets that illustrate the concept of linear regression, okay? So this time, instead of asking ChatGPT, we'll try with Copilot. So we ask Copilot, okay, list examples of data to present to my first year students of linear regression, okay? So Copilot will come up with three options, three data sets. One of them is teen birth rates and poverty level data, okay? So, and it says something, you can explore how these variables relate to each other using simple linear regression. Okay, so we can even say, ask something else from Copilot and say, okay, describe me how to explore this data set. And Copilot will come up with 3 steps. The first one will be something that can be described as a pre-processing step. So it will tell you to do something. Then it will say, okay, it will give like a starting code, Python code on how to generate a scatter plot. And finally, it will help you, or it will help the students with the interpretation of the scatter plot. Okay. So, and so I'm open now. Open the floor for questions or comments, suggestions.
All right, thanks, Anna. So I posted in the chat the link to the webinar page that has the links to your course site and to the resources that you referenced and showed. So those are already there. If anybody hasn't had a chance to look at those. But if anybody has any questions, feel free to unmute or post them in the chat. I had a question, Anna. So you said you taught this course asynchronously during like the pivot for the pandemic. And so I guess that might have been kind of, you didn't have a lot of time to prepare. And I'm wondering, like, if you were to teach this again online, like, did you think of any things that you would do differently as far as activities or structure?
If it were asynchronously, you mean?
I mean, yeah, or just online. Like it could be,
Online.
like
Yeah,
however you do it.
I think that it's good for the students to have that immediate feedback. I think they appreciate that. So maybe asynchronously, not totally asynchronously. Maybe we can meet virtually. It would be better to meet virtually and have that discussion, face to face, even virtually. Yeah.
Mm-hmm. Yeah. Or maybe use some of the activities for the students to do, like, small group work.
Exactly. Yes. Yes.
But yeah, all the activities are really great to kind of figure out, to get students to work on problems that illustrate the concepts.
Yes.
Hi, Anna. This is Linda.
Hello.
My question is, did you see a significant difference or a high or low percentage of the quality in the questions that you were able to generate, the multiple choice questions that you generated using ChatGPT? And did you then actually use those questions when you taught the class?
No, this is, the last time I taught that class was, I remember I am retired. So the last time it was about more than 2 years ago. So you know that this ChatGPT is within the last year. So I haven't had a chance to try the multiple choice questions with the students. Yes, but it would be great to be able to try with the classroom.
Yeah, maybe we can get somebody who wants to use the materials to try that out and actually give us some feedback back
Yes,
on that.
yes,
That would really
exactly.
be good to get.
I was wondering, this is Dave Joyner. I was wondering if you could speak to the follow-up with the students who took the course afterwards. Were there um, additional opportunities for them to use these skills in research and other classes?
Yes, I remember there was one student, well, there were a couple of students, one of them from the physics department, and he was very interested in the course because it was helpful. It would be helpful in an internship that he was planning to apply to, and he was accepted. And he told me he was very happy, especially with the programming.
Yeah.
And also there was another. It was a girl from the biology department that she also she asked me for a recommendation, and she applied to an internship also.
Did you have
Yes.
good feedback with faculty in the departments as well? This seems like we're trying to do similar things here in terms of developing some cross-disciplinary courses, and it's not just the curriculum development; it's getting getting the faculty in those other departments to say, yeah, we have use for our students having this, and we'll follow up with it in our classes.
Yes.
I was curious kind of what your interaction was with your bio faculty, with your chemistry faculty, with your physics faculty after developing the course.
Yeah, well, it was like it has been offered only 2 times, but for example, the director of the biology department was very interested in computation. So it was an upper channel there. So it was a good relation, and also with the physics department. Those two departments, I think there's a good vibe. There was a good environment to further plan some other kind of activities.
Cool. Thank you.
So a question in the chat is, was there a difference in student performance for the two different modalities where you offered the course?
Well, they all did okay. They did very good. But I think that it was easier for the first one, the flipped classroom modality, because they got the immediate feedback. These other students, they had to wait, and it's for the professor, it's quite a time consuming because you have to grade everything and write some feedback, So that was very time consuming for the professor, but it's not immediate for the students. So, and then, they didn't make good use of the office hours but they did okay. They did okay, yes. In both modalities.
And I think you mentioned this, but what are the background courses or prerequisites required for the course?
Just college algebra.
College algebra,
Yeah,
right?
just
Yep.
college algebra, yes.
And as far as the computing resources, it was all just free software that students could download to their laptops?
Yes, yeah. It was for the spider and the anaconda. Yeah. There's one video that explains the download of Anaconda so that they can install it on their laptops.
And is it recommended that students purchase the book for the course, or is most of the material available through your handouts?
Most of the material is available, but I think some of them did buy the course, the book. Yeah. Yes. Yeah. But I didn't ask them to, but they did.
Anybody else have any questions? Thoughts? Have you done anything similar to the course or using these tools?
Yeah, I'll say a word or two. I teach a course that's called computer simulations, but I tend to distinguish between a model and a simulation. I tend to think of a model as starting with the minimum necessary to get at the ideas of the topic. And a simulation is an attempt to sort of include everything that might possibly be relevant. Or sort of one is bottom up and the other is sort of top down. And I find that colleagues in other departments, biology department, for example, they like the idea of put in everything and see what matters later. Social behavioral type of people tend to like, let's see what minimal hypotheses we need to get some understanding of the system. And to a certain extent, that tends to be a difference between sort of, how to say it, calculus-like simulation stuff, where you can actually, solve differential equations, et cetera, as opposed to agent-based models, where, if you're talking about people, you don't solve differential equations to understand their behavior. You build a model and have them interact. And to do that, I tend to use the NetLogo system. I don't know if you've looked at that. It's much more an agent-based modeling system rather than a MATLAB type, say, differential equations, linear algebra approach. I wonder if you could say a few words about that.
Okay. So he's saying to me.
I mean, I can
Okay.
say something
Well,
if you want to.
since this is a foundational course, so we are trying to basically, develop those basic skills, and so that they can do their programming, their computing. But I know that there are other tools that can be used and are very valuable. So, but this is, a foundational course, and it's within, within a department that has, the prerequisite and specific standards. So, yeah.
Yeah, your course you only wanted to focus on using Python as your main tool, right?
Yeah.
So I mean, it's interesting. I like the idea of kind of describing, how to build a model and how to build a simulation as sort of coming from different directions. And so I wonder if your course is it something that is taken by a lot of the students from different disciplines, like Anna was mentioning, biology and physics and other areas?
It's mostly taken as an elective in computer science, but I do end up with students from ranging as far as psychology to physics, take the course
Mhm.
and try to make it comprehensible to the broad range of potential users of computational models in particular.
Yeah. Yeah, if you look at the project site, if you look at the first webinar series, which is just the introduction to computational thinking, I do mention the NetLogo tools as well as other agent and systems modeling tools.
Yeah, one of the nice things about NetLogo is they have a library of probably thousands
Yeah.
of examples that range across sort of every possible discipline that you might think of. And it also has the nice user interface where you're not just writing Python code. There's a drag and drop aspect to the user interface, which I think is going to be important for students in a broad range of disciplines.
Yeah, it's a great way to introduce them without, having to teach them a bunch of code first.
Good, thanks.
So any other questions or thoughts? Yeah, if you want to share anything, we still have a couple minutes, but I'll just say thank you to everybody for attending, and thank you to Anna for
Thank you.
sharing your work with us and for working with us in the pilot and for sharing the resources of the course on this new site. And to just let everybody know that we have 2 more webinars planned for this series. They're both in May, so it's basically a month from now. The next one will be matrix methods and linear algebra from Dr. Alam Tanuri of Morgan State, and she developed that course as part of the pilot project too. And then the final webinar will be on science gateways for teaching, focusing on computational chemistry courses taught by Dina Tandabani at Clark Atlanta University. And so those will be coming up, like I said, the first one's in about a month, and then the next one is the following week. And we'll have all those on the website, and it'll be the same Zoom link, so you can save this and put it on your calendar and join us again in a month. But thanks again, everybody.